Wait, so I was going to send you a voice note about this anyway, but so about complexity theory, right? This theory that all emergent behaviors are the product of a simple rule set, Conway's game of life. There's, I think, 5 simple rules that each one of the nodes in the matrix follow, and just every time the matrix is updated, they check all those rules, and that's how you get the progression of Conway's game of life. And they found that a lot of emergent complexity behaviors from insects follow these rules. For example, someone did an analysis of ant colonies, how they build their ant tunnels, and they found that ants, it's the same thing with bees and wasps and a lot of other ants that do things that are complex. They're following a simple set of rules, and somehow the simple set of rules is baked into their DNA. So, for example, when an ant builds their ant tunnels, they pick up the first rule is they pick up a grain and they check to see if it has been marked with a pheromone marker. If it hasn't, then they mark it with pheromone marker, and then they put it, if there are no grains around them, they put it down. If there are grains around them, they put it on top. And if there are grains above, then they put it to the side. That's all the rules. And from those rules, that you can get these really intricate, beautiful ant colony structures where they have these interesting symmetrical patterns. But the ant is just following 4 simple rules, and it doesn't really know. The ants are not communicating with each other with language, as far as we can tell, or chemical signaling. They just know to follow those 4 rules, and they build whole colonies without needing to communicate. And that's complexity theory. It's supposed to supposedly be the reason why life evolved some way in the molecular interactions between the earliest life soup that was on Earth. Some complexity emerged. I don't know. Anyways, but the process of so somebody figured out complexity theory, which is a great theory, and then process of trying to figure out what those simple rules are when you find emergent behavior, that is called generative reverse engineering. It actually apparently has different names depending on what science it's used in. So if it's used in data science, it's called something different, or if it's used in grammar, it's called rule induction or inverse problem complexity solving in the hard sciences like physics. So this is what I'm doing though. This is all that I'm doing is see emergent behaviors. And for a long time, I thought I was doing teleology because teleology has a lot of overlap with what I am doing, because teleology is all about the only difference really between figuring out the basic simple rules that govern it as a complex system with emergent behaviors and properties and teleology is that with teleology, you plan the structure in advance. And with this complexity theory stuff, you don't plan the structure in advance. You just have simple rules, and the structure emerges as a result of the rules. And so they're so close together in my mind as to be 2 sides of the same coin. But I guess I don't think I will call what I am doing applied teleology anymore. It's applied complexity theory. I'm trying to reverse engineer the simple rules that govern the complex behaviors of social life and society and living well. And anyways, that's what I wanted to say. This is actually pretty validating for me because I didn't know that that's what I was doing, but it is what I'm doing. Now that I know about it though, it's kind of a simple explanation for what I'm doing. There's a lot of trial and error. I think of a simple rule that could potentially apply to create the emergent behavior that I see in the world. And then I just run thought experiments to see if it bears out. And that is not a complex process. It's just like a lot of trial and error. I think it's a very creative process. I think you have to be creative. You have to really get into the weeds and the details of how the emergent behaviors try and really think creatively about what simple rules could create the emergent behavior. But it's not like it's rocket science. I don't think you need a lot of training in order to do the kind of work that I am doing, which is part of the reason why I have been convinced for some time that I think that AI eventually will be doing what I'm doing better than I can do it, A. And B, I think that thinking of it this way might actually make it easier to invite other people into the task, because it's kind of just like a lot of trial and error. But if there was just a way of keeping track of what things have been tried and what things haven't been tried, then you could potentially have a lot of people collaborate on it and solve the problem faster. Okay, that's all I want to say.